In this video, we're going to look at the first principle. So, if we have dy over dx being equal to f prime of x, the first principle is defined as the limit of the limit of this function as h approaches 0. So the function is f of x plus h minus f of x divided by h. So this is how the first principle is defined. Now let us dive straight into answering some questions. So if we have f of x, so we have f of x being equal to x. That's the f of x being equal to x. Then we are told to differentiate this function using the first principle. We know by the power rule that since I have x like this, and I know that there it's raised to the power 1, if I multiply that by, or just the way it is like this, when differentiating f prime of x is going to be, so x here, the 1 minus 1, so it's going to be minus 1, then I get x equal to the power 0, and this will just give me 1. So the differentiation of just a variable like that, x, will give me 1. But how do I get this using the first principle? Okay, so now let us get this using the first principle. So what you do is you have your f of x being equal to x. So what you do first is you say f of x plus so you replace, where there's f of x, you replace x plus h. And we see that if I replace x plus h where x is in my function, and my function there's only x there, I'm going to get x plus h. So then according to the formula, we say f prime of x being equal to the limit as h approaches 0 like that of f of x plus h minus f of x divided by h. So now this is going to give us the limit as h approaches 0 like that. So what is this? So I have already written f f x plus h is going to just be equal to x plus h. So that is going to be x plus h. Then minus my function f of x is just x. Then that would be x. Then divided by h. So from here, what do I get? So from here, say the limit as h approaches 0. So here, the x and the negative x subtract, you get 0. Then you have h remain and divided by h. I know this is just going to be equal to the limit of h as it approaches 0 to be equal to 1. And I know I have no h remaining here, so this is just going to be equal to 1. So we've used the first principle in order to differentiate. Let's look at another question. So suppose we have f of x being equal to, let's say it's equal to x squared this time around. So we know from the power rule that this will give us 2x like that. Now let us get it using the first principle. So you will say f prime of x is going to be equal to the limit as h approaches 0 of, okay, so now what is your, we're saying f of x plus h minus f of x divided by h. So you need to get this f a x plus h part. So where there's, so you say f of x is equal to that x squared. Then where there's x here, we're replacing x plus h. So even in that function here, we replace x plus h. So we have x plus h equal to x squared. So that is what is your f of x plus h. It's just function that is x plus h squared, like that. So from here, what do I do? So I'll say the limit as h approaches 0, so there I replace. So I have x plus h squared minus, what's the function? Function is just x squared, so that will give me x. I have x squared divided by h. So from here I can expand. That. I'll have the limit as h approaches 0 to be equal to. So when I expand, I get x squared plus 2xh plus h squared minus x squared over h. Then from here, I'll say the limit as h approaches 0 is going to be, so this x and the negative x will cancel out, and I'll just remain with 2xh plus h squared divided by h. Then from there, I have what is common, which is my h, so I can factor out an h. So I have limit of h as it approaches 0 is going to be, so when I factor out h, I have h equal to 2x plus 2x plus h, then divided by h. So my h and my h will divide, and I'll have limit as h approaches 0 to be equal to, so I'll remain with 2x plus h. So now from there, what do I do next? So what I do is, okay, so I'm remaining with that. So where there's, so it's saying the limit as h approaches 0. So where there's h, I replace 0 there. Then I'll have that f prime, so to be f prime of x to be equal to, so 2x plus 0, which is just going to be equal to 2x. So we've used the first principle to find or to differentiate that. Let's look at another question. So let's say we have our function f of x to be equal to root of x, like that. So how do we do this one? So we will say f prime of x is equal to the limit as h approaches 0 is going to be, so we say f x plus h here, what will be this? So we replace that there, which is there, then that means we replace where x is. So I have this equal to the root of x plus h. So this is going to be, so in the first part, the formula is f x plus h minus f of x, like that, divided by h. And this is going to give me limit as h approaches 0 to be root of x plus h minus root of x divided by h. And this is going to be equal to, okay, so what do I do from here? So I have this root of, and then I have h, like this. So at this point, what I can do is I can multiply by a conjugate of the numerator to get rid of this. So I need to get rid of this root, like that, because at this point when I replace 0 here, I replace 0 where h to be undefined, so I need to get rid of that and work out. So I will multiply the top and the bottom by, so I'll multiply by h plus h, x plus h plus root of x, then even there down x plus h plus root of x, like that, and multiply that. Then I'll get limit of h as it approaches 0 to be, so that these here will cancel out or square out, like that. Then I'll have so I'll just have x plus h minus x over, then what will I have there? I'll have h over root of x plus h plus root of x, like that. From here I can see that my x and my x, negative x here, cancel out, then I'll just remain with h on top. So I'll have the limit as h approaches 0 of h over h root of x plus h like that. Okay, okay, like that. Then plus root of x. Then here I can divide there into that one. I'll just remain with 1 in the numerator. Just remain with 1, then I'll remain with that other root there. So I'll remain with the limit as h of x approaches 0 is going to be equal to 1 over root of x plus h. Then this is plus root of x, like this. Then where there is h, I can replace my 0 now. Then what I have, okay, so I can replace my 0, and what I have is I have 1 over root of x plus root of x, and this is just going to be equal to 1 over 2 root over x, like this. So this is my final answer. Right, now let us do last question. Let us look at one last question. So we have a function f of x to be equal to 1 over x, and we're told to find the derivative using the first principle. So I'll first find my x plus h. So this will be just 1 over, where x is, I replace x plus h. Where x is, I replace x plus h. Then I'll have x plus 1 over x plus h. Then this will be f prime of x to be equal to the limit as h approaches 0. So approaches 0, then I have my f x plus h to be 1 over x plus h. So that will be 1 over x plus h. Then minus my function is just 1 over x. Then I have h there. So what do I do from there? So I can make that into a single fraction. I can make that into a single fraction. I have f prime over x to be the limit, to be equal to the limit as h approaches 0. Then I'll get the common denominator there. It's just going to be x plus h, then x. So this is going to be x. Then I have so when x divides there x, then I'll just remain with this multiplying by -1. So this will be minus x plus h. So that's what I'm getting there on top. Then divided, this is all dividing by x, by h. Okay, so what do I get from there? So from there, what I do is, okay, so from there, what I do is, okay, so I have this here which I can rewrite or expand. Let me expand what's on top. I'll just have x minus x plus h divided by, then I have x plus h, then I have x, like that. So this is all dividing by h. Then I have the limit there as h approaches 0. So what is this going to be equal to? Then there I'll get 0. So I have the limit as h approaches 0. Then now just remain with h divided by x plus h, x, then divided by h, like that. Then from here, what do I have next? So what I can do is, I'll say this will be the limit of h as it approaches 0, the limit of this function as h approaches 0. Then I'll say h over x plus h, x, then that will be multiplied by, so there that will just be 1 over x, like that. And then this h divides that h, then I'll just have the limit of h of 0, then there I'll have 1 over x plus h, then I'll have x. Then here I can replace my h. So when I replace my h, I can replace 0 with h there, then I'll just have f prime of x being equal to 1 over, so when I replace there, I have x plus 0, then x, like that. And this x plus 0 is just x, then x multiplied by x, I get x squared. This will be 1 over x squared. So that's how I solve this question using the first principle. Alright, if you did not subscribe to this YouTube channel, remember to hit that subscribe button for more videos.